Hey, good evening, everybody. Okay, welcome to Babalin Physics Classroom. Okay, this section here we look at is 2.3 of our kinematics, graph of motion. Okay, this particular section here, this particular topic here involve two sections. Okay, namely the describing of the graphs. Okay, then after that, using the graph, the next tier you need to do is to do calculations from the graph. Other other than using the information given to you, you also use the math to actually derive additional information. Okay, such as distance, time, acceleration, speeds. Okay, so we'll look at these two sections step by step. Okay, first, we look at the describing of the graph. Graph of motion. Okay, graph of motion, generally there are two types. Three are to be exact. Okay, one is distance time graph, the other one is speed time graph, and the third one is acceleration time graph. For secondary school context, generally the graph that appear quite commonly is actually distance time graph followed by velocity time graph. Okay, so we'll look at these two graphs in detail. The first graph that we are looking at is distance time graph. Of course, distance time graph, what we are looking at is that the axis is distance, y-axis is distance, the x-axis is time. Of course, from here, the marker will expect you to describe the motion. What is the graph trying to portray? What information is it trying to portray? Okay, so the horizontal line here, what we mean is that the constant, you will tell if it's a horizontal straight line, okay, it means that at every second the distance is constant. So in this case, for distance time graph, the information that the graph is trying to tell you is actually that your object is actually staying at the same place every time, or what we call stationary. So the other information that we look at, if we look at describing graph, we are not like describing anything and everything under the sun. Okay, there is a certain method of doing it. Okay, so when we describe the graph, actually we look at one thing, we look at the gradient of the graph. Okay, so when we describe the gradient, when we describe any graph, the first thing that the marker expects you to write is actually the gradient. And that gradient actually has certain information. So you're going to interpret gradient, interpret it to the correct information. For example, if I give you a distance time graph, okay, the gradient of a distance time graph will give you speed. So which means if I need you to describe the gradient distance time graph, I expect you to tell me about the speed of the object. Okay, not anything on the side. It's not I will not accept you telling me, oh, this distance is increasing with every second, every minute, all these things. No. Okay, so the information I need is actually speed. Okay. Now for distance time graph, gradient wise, okay, I would say if it's a curve, I'm looking at tangent or what I call instantaneous speed. Okay, so when I describe a curve, okay, distance time graph, when the distance time graph is a curve, okay, I'm looking at the gradient, and specifically for curve, when we're looking at gradient, I'm actually looking at tangent. Okay, so how does it work is, I'll look at a particular point, let's say 5 seconds. Okay, 5 seconds, I will expect to draw a tangent, okay, which is this dotted line here. So this dotted line, you look at the y-axis, which is the change in distance, thereby change in time. Okay, this will tell me the speed of that particular of the object at this particular timing, 5 seconds. Then if I want to look at the another timing, I want to do a comparison. Let's say I look at comparison at 10 seconds. Same thing, I'll repeat again. I will draw the tangent and I'll look at the gradient, because gradient of a speed distance time graph gives speed. Okay, so same thing, I repeat the same thing again. I draw the tangent, I calculate the speed. Okay, I'll calculate the gradient. Okay, the gradient of this line, which give us speed at this instant, which is instantaneous speed. So you can see that based on the gradient, the gradient of the graph is actually at 5 seconds and 10 seconds. The gradient of the line is actually what I call increasing, or sometimes we say steeper. Okay, when you have a steeper gradient in a distant time graph, it means that the gradient is increasing, or I can say that the speed of the object is actually increasing. Okay, so if you look at the describing the information I need students to see out is actually the speed is changing. How is it changing? It's actually increasing. Okay, so other than that, we have another information that we can derive from this distance time graph, which is average speed. Average speed, remember, is total distance divided by total time. Okay, instantaneous speed is the speed at that particular instances. Okay, so if you look at instantaneous speed, we are looking at the gradient of a tangent, okay, which is what you need to draw for the graph. Okay, as for average speed, okay, this is instantaneous speed. So what for average speed, the information that you can sieve out is actually total distance divided by total time. It's not the gradient, it's actually the y-axis. Okay, the total, the total vertical height. So for example, at 8.5 seconds, okay, 8.5 seconds, for average speed is total distance is, I'm just looking at literally the y-axis, the total distance that have been traveling through at until 8.5 seconds, and the time taken is 8.5. Where this is the total distance by total time. Okay, but if you look at instantaneous speed, like I mentioned before in the previous slide, okay, it is looking at the tangent. So you need to draw a tangent, and you need to take a look at the delta distance, the change in distance, thereby change in time for this particular tangent. Okay, and that would be the instantaneous speed. So if you look at the information, although they are from distant time graph, I'm looking at to sieve out information speed, but different values of distance, different value of time actually give us different type of speed. So I can have average speed, or I can have instantaneous speed being sieved out, the information being sieved out from distant time graph. Okay, so before we go to speed time graph, okay, just to make sure everybody's on the same page. Now, the baseline that we are looking at when we describe distance time graph is we always describe the gradient. Okay, so normally average speed, I would say that I will wait for the question to prompt me to find, then I find. If I need to do describe, I always find instantaneous speed, or I relate the distance time graph. Okay, what factor of distance time graph? I relate the gradient of the distance time graph, relate it to speed. Okay, this is the thing that I will do. Okay, I will not use average speed. I will usually wait for the questions on the marker to tell me to find average speed. Then I find. Okay. Now, the other graph that we talk about is speed time graph. Speed time graph is the second type of graph that is commonly available. Okay, so from distance time graph, you'll find that if you look at this, okay, for let's say for stationary, okay, stationary distance time graph is a straight line, like you see this first graph before. Now, how do you convert the distance time graph to the speed time graph? Okay, it looks complicated. It's not complicated, it's actually quite easy. Okay, you look at stationary distance time graph is a horizontal line. It means that the object is the same distance every time. Okay, it means aka what we call stationary. So it is not moving, so mean the speed is actually 0. Okay, now, so for the questions, so for distance time graph to speed time graph, how do we go about doing it? Okay, so we look at a second example first. Okay, we look at second example first. Okay, so now for second example, distance time graph, you'll find that the distance is increasing. 1 second, 10 meter, 1, 2 second, 20 meter, 3 seconds, 30 meter. So you can see that based on the distance time graph, the object is actually moving. Okay? The distance is getting further and further away. Okay, so it's moving away. So which means that if I'm going to find distance time graph, remember distance time graph, the gradient of the line give speed. Okay, so from distance time graph, how do I find speed? Is I will actually go and find the gradient of each line, gradient of each point. Okay, so what I do is get another color first. Okay, I'll find, let's say at time t second. What I want to do, I will find the gradient at this point, which is change in y, change in distance, divided by change in time. Okay, this will be the gradient, change in y over change in x in terms of math. Okay, that will be the gradient. Okay, so that gradient is what we call speed. Then after I will record it as speed for time 2 seconds. So likewise, if I do the time equal to 5 seconds, okay, I will find a gradient at this point, which is change in distance divided by change in time. Okay, I will have the speed, because distance time graph, the gradient is speed. Okay, so this is the context that we have to be clear. So once you find the gradient of a speed time graph, out of distance time graph, you'll find that you will give us speed, okay, which is in this case is constant now. Okay, because the straight line graph is a straight line graph, upward sloping, the gradient will be constant. Okay, so from here, simple example here, you can see that, okay, where we have a distance time graph, to transform distance time graph to speed time graph. Okay, what we are literally looking at is actually the distance, the gradient, sorry. So which means for distance time graph, okay, for distance time graph, where we look at distance time graph here, I want to transform distance time graph to speed time graph. Okay, so the transformation that I'm looking for is actually I'm looking to find the gradient. Okay, the gradient of distance time graph will actually give rise to the speed time graph. Okay, so similarly, okay, if you extrapolate this understanding, you'll find that if I have a speed time graph, the gradient of speed time graph will actually give me accelerations. Okay, so this is what we are trying to do. So when we move from graph to graph, we are actually looking at one thing, which is the gradient of that particular graph. Okay, so distance time graph, okay, speed time graph, okay, they are related because these two graphs I can actually interswap. Okay, from one graph I can swap to another graph. How? By looking at the gradient. Okay, by looking at the gradient of a distance time graph, I can actually get speed time graph. Okay, which is one of the important things that we are looking at. Okay. So similarly for speed time graph, okay, if I'm looking at the speed time graph, I will know that the gradient of a speed time graph will give me another information, and this information is acceleration. Okay, so if I saying that the speed time graph, the gradient is horizontal straight line, aka the gradient of a speed time graph is 0. I am indirectly saying that the accelerations of the graph is actually 0. Okay, so remember what we are looking at is we are looking at gradient of one graph, give the information to the next graph. Okay, so similarly, you will have encountered different graph. Okay, so if you look at distance time graph, if I want to transform it, I'll look at the gradient. So you find that the gradient is getting steeper and steeper. Okay, getting bigger and bigger. Steeper means bigger, so you'll find that the gradient here will actually, the gradient of a distance time graph will give me speed. So the gradient is actually telling me about the speed, Okay, so that's why I will be able to plot the speed time graph of this particular object. And similarly, if I were to find the gradient of my speed time graph, the information that I'm getting at is actually acceleration. Okay, so this is how I transform from one graph to another graph. Okay, so if it's increasing speed, or what we call increasing gradient, okay, it will means that the speed time graph, okay, is actually increasing. And if my speed time graph has a positive and constant gradient, it will mean that my acceleration will also be constant. Okay, because the gradient of the current graph of this graph gives the information of the next graph to the next graph. Okay, so this is what we are looking at. Okay, at different graph, you perform the same thing. You look at it, we have different graph. Okay, you will have different shapes, but all the shapes actually has the same treatment. You look at the graph, you look at the gradient, and you actually tell you the next information about the next graph. So in summary, you will find that if you look at speed time graph, okay, if you're describing the graph, you'll find that the acceleration of a speed time graph, okay, the acceleration of a speed time graph, how do you find the acceleration of speed time graph is actually from the gradient. So if your speed time graph have positive gradient, it will mean it has accelerations. Constant positive gradient, it will mean constant accelerations. If I have a decreasing positive gradient, it means that it will have a decreasing acceleration. Okay, likewise, if the gradient is negative, it will mean it's a deceleration. Okay, so if we talk about describing the graph, okay, there is a technique that we always look at, which is looking at the gradient of the graph. Okay, so with this, okay, before we move on, okay, we will look, okay, we will do a brief stop here. So if case, okay, if you are not sure how to describe the graph, okay, go back at least like maybe 20 seconds ago, okay, look at how I describe the graph. Okay, the primary main thing that you're looking at is the gradient. Okay, so if I have a distance time graph, how do I transform it to a speed time graph? I will actually look at the gradient. Okay, be it positive or negative. Okay, it will give me the speed of the next of the next graph, which is speed. Speed time graph, if I look at the gradient, it will give me the information of the next graph, which is acceleration. Okay, so the acceleration graph, okay, will actually derive the data on the acceleration time graph will actually derive from where? From speed time graph. Which segment of speed time graph? The gradient. Okay, go and take a look at this brief way of describing. Okay, get familiarized yourself with this and hope that it will be you will be able to see some logic between the math, the gradient part to the describing part. Okay, so the next segment that we look at will be the calculations, using speed time graph to do calculations. Okay, so thank you everybody.